Dan, thank you for that introduction, and thank you to the whole group for having us on today. Excited to share a little bit about our work, and then more importantly, hear what you all have been working on. So I'm going to talk a little bit. My name is Jordan Branham. I'm a team leader here at Argonne National Laboratory. And before I get rolling, I'm joined by Tom Wall, our director of Center for Resilience and Decision Science. Um, I'm going to talk a little bit about the Climber portal, as well as some upcoming additions we have. And then Tom's going to finish us out talking a little bit about some of the more recent advancements in this space. And that includes some ongoing collaborations, engagements with NOAA as well. So, Tom, is there anything up top that you wanted to add there before I jump into it?
Nope, that was great. Thanks, Jordan.
Awesome. So big picture, Climber was launched back in late 2022, I believe. Public-private collaboration. It was a partnership between Argonne, the Department of Energy, and then AT&T as well, who's been a long time partner collaborator in this work with Argonne. It was launched as a website to try to improve access to environmental and natural hazard risk information, with a goal to kind of reduce some of the complexity to a certain degree and aid the communication of this information to a broad audience, as you can see there with that last bullet point: individuals, organizations, planners, officials, just ultimately to kind of help analyze hazard risk to support decision making, and also as part of that, provide data sets that can help contextualize some of those risks. So it is from the get-go been a work in progress in terms of how Climber looks today. Looks very different than what it looked like in 2022. New data sets, new capabilities have been added since then, and then a lot is planned for the next year and beyond. And really, a lot of the data that is up on Climber right now is focused on the data from our ADA data set, which is the Argonne Downscaled Data Archive. There's a version 1 of that data, and then there's a version 2 of that data. Climber is designed to be able to be host to more than just the ADA data set. It includes right now infrastructure layers, demographics, such and other similar data layers. But it does not need to be necessarily confined to ADA. That's just the data that we have readily available at Argonne, and kind of our initial focus here as we launched Climber. The ADA data set, the version 1 data set, has its roots about a decade ago or so in funding from the Department of Defense, now Department of War, to downscale several GCMs using the weather research forecasting model to a higher resolution. So this first iteration of the data, the stuff that's up on Climber right now, is downscaling down to 12-kilometer resolution using a 3-hour temporal resolution. And I probably don't need to go into the details on this call, but the dynamical downscaling process is a physics-based approach, and so as part of that, we needed to be able to have access to supercomputing to be able to run these models, which took a couple years. That supercomputer is what is pictured in the upper right corner there right now, and it took an immense amount of computing resources and then also storage resources to be able to produce these data. We downscaled 3 different GCMs. One is the GFDL model, one is the CCSM, and then third is the HADGEM model, to try to capture some of that spread in the climate sensitivity of those models. Knowing that in an ideal world, we would downscale all of CMIP5 at the time, but just didn't have the compute to be able to do that. And then we focused on 3 different time frames: a historical 10-year period oriented around 2000, mid-century 10-year period oriented around 2050, and then an end-of-century period oriented around 2090. For the mid-century and end-of-century period, we ran 2 of the RCP scenarios, RCP 8.5 and then RCP 4.5. And then I would be remiss if I didn't mention that we're running the ADA V2 data as we speak. That is at a 4 kilometer spatial resolution, 1 hour temporal resolution, and a target of 20 years for each of our scenario chunks, historical, mid-century, end of century is definitely yet to come. That has taken a whole lot of compute and a lot of time, but we're excited for what that's gonna look like, and hopefully resolving convection, what it'll be able to offer. Yeah, Tom, jump in.
Yeah, thanks, Jordan. I was just going to address Ellen's question in the chat about bias correction and climber versus not
Mm-hmm.
bias correction. It's been the hot topic of much discussion over the last couple of years, even of do we bias correct or do we not bias correct? The 12-kilometer data set that's currently the basis for most of what's on Climber is not bias corrected. We are evaluating different methods to bias correct the 4-kilometer data. That'll be sort of the future of Climber. But even then, right, like we don't, if we were to provide that, it would be to provide both data sets, bias corrected and unbiased corrected, and try to appropriately contextualize that. One of the, I mean, as I think most folks are aware, one of the benefits of the dynamical downscaling process is preserving the internal consistency and correlation between different variables in the climate data set. And if we start bias correcting individual variables, we lose that internal consistency. And in particular, in the electric sector, there's a lot of interest in compound hazards. The scenario that I always give as an example is like if you have a heat wave in Chicago, but the wind isn't blowing in Iowa, where a lot of wind generation is, that creates a larger worst case scenario for power utilities. And we're able to start examining some of those types of questions with the correlated variables in the data set. I view the bias correction largely as a communication challenge. What we've run into is when we've hosted data on the portal, someone will look at the historical model runs and say, the average temperature is 75 degrees. Well, historical record says it's 78 degrees. Your data is wrong. It's bad. It's something like that. And we can bias correct that and try and get it closer. But it's also, there's downsides to that in how we can use the data for forward-looking projections and helping, in particular, utilities better evaluate that. So there's like a push and a pull, at least from the use cases that we see of bias correcting versus not bias correcting. What we're currently doing is we've developed one method where we can maintain correlation between multiple variables, or at least key variables, in the bias correction process. It's pretty fiddly and it doesn't work extremely well. So we're looking at are there other methods that we can employ to try and preserve some of that correlation between the variables. But it's been like, as I said, the topic of much internal discussion, because we recognize that if particularly less technical users are looking at this and see differences in historical model runs and historical record, that they then sort of question the validity of the data when there's good reasons to try and preserve some of those differences. And in particular, a lot of the focus from utilities has been on a comparison of sort of change from historical to future. And it's our assertion that the bias that exists in the historical runs is also in the future runs, and that to some extent those cancel one another out. Not completely, but to some extent they may. And so for those change values in particular, bias corrected or not bias corrected, we still see some validity there. So that may be more information, Ellen, than you were asking for, but I just want to assure everyone that it is it's the topic of much discussion and debate. And even when we talk with we have a lot of lively discussions with the folks who run the CalAdapt portal in California and Eagle Rock Analytics. And it's been the focus of a lot of our discussions with them because they're wrestling with some of the similar questions. So fun chats about bias correction that we've been having, and I'm sure we'll continue to do so.
Thank you, Tom. Appreciate it.
Yeah, thanks, Tom. Just FYI, in order to kind of manage the agenda and keep us on time, we generally reserve questions for the end of the talks.
Sure.
I apologize for not making that clear up front. I know we've got a lot of new people, so If we'll let Jordan and Tom get through their presentation, and then we'll entertain some questions. And no need to worry about it, Ellen or Tom. You guys are kind of new, so sorry, that's on me. Anyway, go ahead, Jordan. It's all
Awesome.
good.
Thanks, Dan. And Tom, thanks for flagging that. I can't see the chat right now, so don't want to ruin anything. Okay, just really quickly to kind of keep things moving, did want to cover what we currently have up on Climber as far as that added data goes. Again, I mentioned what's not listed here is some of that infrastructure demographic data that's also available. But we currently have the Canadian Fire Weather Index. So that incorporates temperature, relative humidity, wind speeds, and 24-hour precip, I believe. We have average temperatures. We have heat index data, both in terms of seasonal averages and days above certain thresholds. Just last summer, we released wet bulb globe temperature information, which we were pretty excited about. So that includes not only temperature and humidity, but also the cooling effect of winds and then the warming effect of solar irradiance. And then we have a lot of your basics after that, some precipitation information, some wind speeds, days with no precipitation, degree days, which was really important, again, with a lot of our utility applications, heating and cooling degree days. And then we have some inland flood models that use as a key input that add a V1 data. And then I mentioned at the bottom two of the more short-term future integration things that are on the 5 and 10 yard line pre-release. One is growing seasons information, focusing specifically on freeze-free days and the length of the growing season. And then another one is heat waves, and I'll get into that in a moment. Navigation-wise, we have a couple different ways to explore the data that's up on Climber. One is our bread and butter, I would say, the local projections tool, where we recommend most new users go. That's for clicking on a location and trying to retrieve as much information as possible about that location. And there's a lot of analytical tools available within that structure if you want to stay on the website. So that's our first and one-stop shop. Then we have National Map Explorers, which the name is apt. It's a good place for exploring national maps of the data. And then lastly, for those that want to take this down and work with it in QGIS, ArcGIS, Python, etc., we have the data catalog where you can go download the data directly as well. Did just want to give some examples of what this looks like in action. So here's an example of the local projections tool showing some data for the wet bulb globe temperature. And specifically, you can see that I'm selecting a location. This is actually where Argonne National Laboratory is in the 12-kilometer grid cell that covers Argonne. And then you can retrieve a host of tabular data below. And then there's also different ways of interacting with figures on the left. In this specific instance, a lot of our data to date has focused on presenting annual and seasonal information. With wet bulb, we started to transition more towards a monthly cadence. And this is an example of seeing some seasonal data over here and some monthly breakdowns over here to be able to get a sense of how those shoulder seasons might shift at mid-century. And then here's an example of what the national maps look like. Again, this is a change layer for the wet bulb globe temperature. In general, Ellen, to your question, we really emphasize the user's focus on the change. That's the really important aspect of this data, and how we're going to kind of mitigate some of the concerns about that bias is if we focus on the change values, the magnitude, and the direction of that change. So here's an example of that change layer being mapped for wet bulb globe temperature. This is the daytime hours, number of daytime hours above 82 degrees Fahrenheit, and that change from historical to mid-century. Just looking at the time, I'll go a little quickly here. One of our more recent releases, or soon-to-be releases, is an evaluation of intensity, duration, frequency curves for extreme heat. We also have extreme cold and extreme precip coming. And this is based on looking at annual maxima across all of our different grid cells, durations from 1 day to 20 day. We're only going to be presenting 1 to 7 day, just because that's kind of the range in which we found reasonable applications. But this data will look something like what you see on the screen, where we have historical curves for the 2-day heat wave event all the way to the 6-day heat wave event. There will also be a 7 and a 1 day here as well. And then different levels of recurrence intervals or return periods, ranging from the 2-year return period all the way to the 50-year return period. We've also undertook as part of this a bootstrapping approach to kind of capture some of that uncertainty around that median estimate. So you can see that shaded band is the 90% confidence interval around that median estimate, and we have a bunch of ways in which users can kind of interact with this and visualize that uncertainty, both historically and at mid-century. Also, there will be a third feature of this data, which is that a user can actually go in and turn on a map to visualize the temperature for a given duration frequency pairing. So you can see on the right, the 6-day, 5-year return period. What's the temperature for that duration event for that recurrence interval? Same thing for the one on the far right, the 2-day, 50-year event. What's the actual temperature for that duration frequency pairing? And just as a sneak peek, I mentioned this is on the 5-yard line or so. This has even changed since I took this screenshot, and now includes actual map layers as well. But it's going to look and feel pretty similar to our local projections tool, but offer a little bit different of a setup to engage with this extremes information, including you can see kind of your standard IDF table below, and then an expandable chart where you can turn on multiple different durations, multiple different scenarios, and visualize those simultaneously. Just cover a few upcoming updates, and I'll pass it off to Tom. We have coming later this calendar year is the integration of what we've been calling our Argonne Resilience AI Assistant, or ARAIA, which is the development of kind of a tailored large language model tool set, dedicated chatbot that will live on ClimRR and help users understand the data and then undertake that application piece. How do I actually take these insights from the data and turn them into action and break down barriers to improve decision making? We have IDF curves coming for not only extreme heat, but also extreme cold and precipitation. Precipitation will probably be more like early 2027, cold hopefully later 2026. We are actively working on the 4-kilometer downscale data for CMIP6, as I mentioned, and that is coming down the pipeline. We have a regional climate analogs viewer where an individual will be able to go in and select a location and see, based on several different variables, what their climate analogs are for mid-century. We have that growing seasons data I mentioned. We are working on hourly meteorological data for utility modeling. This is the development of typical meteorological years and extreme meteorological years, TM-wise and XM-wise. And then lastly, we have an effort to develop some dedicated GIS plugin functionalities for QGIS and ArcGIS so that folks can more easily interact with the ClimRR data and bring it into a fully formed GIS interface, one of those two applications. That was a lot really quickly, but I wanted to try to get through that in time. So Tom, it is over to you now.
Cool. Thanks, Jordan. I've just got 2-3 slides here. I wanted to highlight some really cool new work that we're pursuing. We've been, caught up in the AI wave, like I think most other research institutions around the country and around the world. AI weather modeling is, of course, an easy place to start for anybody, whether you're Google or NVIDIA or Argonne, because there's just a wealth of historical and observation data that you can use for training a model. So we have focused on subseasonal to seasonal modeling as opposed to more medium range weather forecasting, which is Google and others are really approaching that pretty capably. And so we've developed the ARIS model for S2S modeling. And our focus, as I mentioned, is to try and go beyond that 14-day threshold. Currently, the model is stable and will run and produce weather out to 90 days. If you go to the next slide, actually, it should be the same text. Yeah, so we've done some benchmarking with other models. GenCast is a Google, I think one generation ago, Google model. And these other models start to break down after 30 to 60 days, but we're still continuing to represent weather patterns on a global scale at 30-kilometer resolution out to a 90-day threshold. We're currently in the phase right now of evaluating, is it any good, the data that it's producing, right? Like just because it's stable and able to represent what looks like a global weather system out to 90 days, starting to look at how well is it reproducing data. What's also unique about this model, and we think very cool, is that it uses this diffusion-based approach that allows us to very rapidly produce large ensembles of probabilistic global forecasts. So the model runs in a matter of seconds. We can do about 10,000 90-day forecasts within about 5 minutes using this model, and produces just massive amounts of data that we can then start looking at probabilistic projections of, all right, 2 or 3 months from now, is there a 20% increase in precipitation over historical norms or something like that. It's a massive, massive model, and this is why we've tried to pursue this here at the National Lab, is because we have access to very large supercomputing clusters. And really, I think the team, we started as approaching this actually as a computing question, right? And weather was just sort of an easy, quote unquote, easy application of how do we build a large AI for science model. We have this supercomputer, the Aurora supercomputer, that's the third largest supercomputer in the world right now, or the third most powerful supercomputer. And we're able to scale the Ares AI weather model to 98% of that machine. So that in and of itself is a large computing and modeling achievement. But then I get really excited because I'm thinking, well, we can start, can we actually forecast weather out to 90 days? And what are the applications for utilities in particular who are looking at forecasting electric load demand on their systems, forecasting potential impacts to their system, so that they can, from a preparedness perspective, try and get ahead of that. If you go to the next slide, is my last slide. And I just will say that this is one use case that our scientists thought was very cool. And so like, hey, how can we look at specific events? And so they went back and looked at modeling one hurricane, Hurricane Laura, which was pretty unique in that it had this sort of late breaking right-hand turn up into Louisiana, when a lot of the models suggested it would hit Houston, and the Ares weather model predicted it's going to turn right and go up into Louisiana. So it was one case study, but I couldn't resist putting it in the slides today because it's something that we're evaluating as something that we could reasonably use for hurricane modeling or looking at specific events beyond this more longer term subseasonal to seasonal forecasting. This is information that we're currently in discussions with folks elsewhere in NOAA right now, with the AI center at NOAA, their director, and also sort of the overarching AI people at NOAA, and have a discussion with NCEP and some of the folks in the modeling side to discuss these models and potential co-production of an AI weather model between Argonne and NOAA. We're meeting with them next week. We recognize that we are mostly computer scientists and folks who are looking at the application space, and that a partnership with NOAA to actually develop a weather model together is really the only reasonable path forward to do something like this. So that's my last slide. If there's any questions for Jordan or I think I'm not quite sure how much time we have, but we're happy to entertain anything. And if we run out of time, please send us an email, and we're happy to handle it that way too.
No, we're good. We can entertain a few questions. Anybody have anything they want to ask?
This is Dennis.
Go ahead, Dennis.
Okay, thank you. I just wanted to bring up the Corps of Engineers. They produce a Mississippi River precipitation trends report every 5 years. They did one in 2019. and one in 2025. And prior to 2016, the river was sort of acting normally. But in 2018, 2019, 2020 were record flood stage years, especially 2019. That was the largest flood record. And then 2022, 23, 24, and 25 are now drought years. The reason I bring it up is that we're submitting a paper for the convention about the impact it's having on navigation, both in the upper part of the river and the lower part of the river. And I was wondering if this group has interfaced with the Corps and the two reports. One was done by Frederick in 2019, and the 2025 report was done by Wolverton, and they are the liaison between I think the Mississippi Valley Division and NOAA. And if the speakers are familiar with that work.
So I will say I'm not familiar with the work. We had been pursuing some flood modeling work in the past. So Jordan mentioned that the collaborators currently on this portal are AT&T, Department of Energy, and Argonne. For the first couple of years of the portal, FEMA was a co-sponsor and participant in that, and so we had interfaced. For political reasons, they stepped away from being a partner about a year and a half ago. But we had been interfacing a lot with the flood modeling folks at FEMA as a part of that project, and really sort of following their lead for liaisoning with other parts of the federal government participating in sort of like these types of forecasts that you're talking about. So I think most of what we would have been, and if they were still a partner, would still today be relying largely upon our partners across FEMA for those types of interactions. And so for that reason, I'm not directly familiar with that report that you're making, but
I'd like to get in touch with. Yeah, I would like to get in touch because the issue that has been raised is evapotranspiration is creating these very short periods between these extreme events, from a flood to a drought.
Sure.
So they were in record flood events for 3 years, then 2 years normal, and then into a record drought. And it's being attributed to this rapid inversion is somehow correlated to evapotranspiration. But that's when y'all brought up those temperature maps and looking at what is going on across the country historically. I think that was why it triggered me to bring it up. So I'd like to be in touch if it's okay to put your contact information. Thank you.
Yeah. Please send us an email. And also, we have colleagues in our environmental sciences division who do a lot of the sort of environmental and climate and weather modeling. I'm sure that they may be aware of it, and they may also have some additional insights that could be relevant to a discussion.
All right.
If you could put your email, and I will do that. I'll email you.
Right.
Thank you.
And just for the rest of the audience here, if you want to reach out to any of our speakers, even past speakers, if you go back and you're looking at the YouTube videos and you want to get a hold of past speakers, just drop Megan or I a note and we'll try to get you hooked up. I've got Dan Barry, then Norma Jean, and then Bilal. So Dan?
Great. Thanks, Dan. Yeah, hi, Tom and Jordan. I am a program manager at NOAA in the Climate Program Office, and my program funds modeling work, so I'm particularly interested in your talk. Thanks for showing up at the task force. I have a ton of questions for you guys, and we'll email most of them, but I think probably other folks might be interested in a couple of the questions. And the first one is, for the downscaling work that you did, what type of validation did you do after generating the data? I'm curious about, how you looked at process fidelity or representation of variability and whatnot, and especially in the historical period. That's one question, bigger question. And then the other question is, the AI work is very exciting, and it's great to hear that you're working with the Weather Service on the weather forecasting element. I'm curious if you've started to think at a conceptual level about how to apply some similar AI techniques or downscaling techniques, like learning from high resolution work, for example, to the projections work, and if you've thought at all about generating larger ensembles in that work, that type of thing, to perhaps capture like different modes of ocean variability and courses that the ocean circulation might take over time, for example.
Sure. I'm going to handle your second question first and ask Jordan while I'm doing that to drop in the chat a link to a box folder we have on Climber that gets into all of the validation and sort of the publications around the 12-kilometer data sets. We don't have any publications currently, or they might be in like under review right now for the 4-kilometer data sets, but I think that will probably address your question on validation a lot more thoroughly than any comments we can make here. So I'll probably punt on that one. But to your second question about longer term, looking at longer term signals in the AI model, right? The AI models are just looking at, or we trained it on Era 5 data. So it's not looking at super long domains, and the models don't necessarily pick up these longer term signals. So there's a lot of sort of internal discussion about how do we introduce these types of longer term signals into the AI weather model so that we could run them potentially for time periods beyond the 90-day threshold. And that's unfortunately something that we don't have funding to do right now. So we'd love to sort of figure out how do we do much longer term simulations and generate much longer and larger ensembles that do capture some of these longer term trends, but we're sort of having to figure out how would we support that type of a work. And it's really the nearer term sub-seasonal to seasonal that seems to have more attention right now. I think how do we, if your question is more how do we look at additional phenomena out to the 90-day period and capture some of that variability, I think that's very much something that we're interested to do. And in particular, the first step has been to develop a model that we could train more rapidly. So we may not need the entire, 120,000 GPU machine to retrain a model with new data sets. And also at the same time, how do we increase the resolution beyond a 30-kilometer global resolution? So there may be processes that happen smaller than the 30-kilometer scale that we want to represent in that. So I don't know that fully answer your question, Dan, but that's sort of the more immediate directions that we're pursuing with the AI weather modeling.
All right.
Yeah, I guess getting a little more at the application of AI approaches to deterministic like lead time forecasting. Like that's a category, but the different category that I think folks have not quite figured out of how you leverage AI techniques like, the diffusion technique that you were talking about in producing higher resolution projections. That was more what I was getting at. And maybe it's, something we can talk about offline or in a hallway, hopefully at some point. But
yeah. And we're talking to like Rich Bandy and Daryl Kleist and folks at NOAA. So if you know those guys and want to come to our meeting on the 25th, I take a very a big tent approach. The more folks, the merrier. So if that's of internal interest to you to make those internal connections and or join us next week, we'd love to have you join.
All right, excellent. That sounds good. And I'm hoping this is not the last conversation we all are having too. So I guess with that, Norma Jean, and then I've got Bilal.
Well, hello, Jordan and Tom. I have two quick questions. But one is two-part because one is about coastal surge flooding. I didn't see anything on, or maybe I missed it, because maybe it's just a continental U.S. model, or is it global? I did see you model Hurricane Laura. So that's question number one. Does it handle coastal surge flooding? Because it says I caught inland flooding.
So yeah, we have done some coastal surge modeling. I would say it was more exploratory than exhaustive. We did some modeling with like some synthetic hurricane tracks, and even if you do 1,000 hurricanes or 10,000 hurricanes, it feels pretty comprehensive, but you spread them across such a long coastline, and it's maybe not as comprehensive as you thought it was. So we do have some data sets that we've produced. We were in discussion with FEMA and some of the coastal flood folks there about, just trying to get comfortable with all the data that we're producing and are they comfortable with the data that we produce and hosted that on ClimRR? And we decided to take a pause on that just because they have a very rigorous approach, appropriately so, to try and do something very comprehensive. We were trying to frame our data as like I said, more exploratory than sort of a comprehensive characterization of future risk. FEMA expressed some concerns about just sort of miscommunication and would there be confusion amongst their users of the data sets. So we said, look, no problem. We won't put it up on the portal and we can punt that to a future discussion. So we've done a lot of that work, but in the interest of trying to be good partners with other federal folks, we decided not to put that one up. But if it's of interest to you, like we have the data, we're happy to share it. So if you have applications in your work or your research, it's there, and we're happy to talk about that.
And the second question is growing seasons. Is that by crop type?
Not.
What a great
this is one of Tom's things he really wants to do at some point. It is not yet. We would love to produce some growing degrees data and also do some kind of crop specific analysis. Right now, it's just a measure of freeze-free days. So for the most part, how many freeze-free days are occurring? When does the last freeze-free day, first freeze-free day, length of that uninterrupted freeze-free growing period occur? So it's very much focused on that. We also have some plant hardiness zones data. Those are not going to be published yet. We're in some having some conversations with USGS about that. But if you're interested in crop specific data, that is something we would love to pursue down the road at some point.
And just a quick added context to Jordan's comment there, the motivation for a lot of the growing season data is from, I'd say we've spoken with, dozens and dozens of utilities at this point. They all have vegetation management departments, and the vegetation management folks are extremely interested in this type of information because there is a massive impact to their budget line in the utility budget when they have to go out an extra month or more frequently to prune trees and manage vegetation around their assets. So that's why we've not pursued the crop specific as much, is because the motivation is ultimately from the utilities and the vegetation management folks.
All right, excellent. So I've got Bilal, and then I think Amanda had her hand up at one time. I'll let Amanda have the final word. Bilal?
Yes, Jordan and Tom, thank you so much for the presentation. I think it's very helpful, it's timely, it's needed. All of this is very important for our national security infrastructure, all of this. But I have a question. There are so many competing products in the federal landscape. And my concern is from engineering perspectives, as being member of ASE for many years, and as familiar with design practices and how maybe some firms operate and so on. When they deal with the issue of climate and they are dealing with whatever application it is, could be rails, bridges, and so on, and they are looking for sources, there will be an element of maybe they don't know where to go, because you have the climate.gov, and now we have the ClimRR at the very end.gov, and you have the GFDL and SPEAR models and so on, which gives items of very important, and we are working with that lab as well. And we have NASA with the Previti model and the push to get applications for it and so on. And for the user at the very end, and each interface there is it does require spending capital, time, and effort, learning curve, right? To know the interface and the use and the limitations and so on. And I've been working in this area for years so far with Dan for maybe at least 15 years. And still we don't have good handle on it, at least for myself, Dan. Maybe you do have better handle than me. But still you'll end up finding, okay, well, what's the limitation? What are the assumptions? What are the resolutions and so on? And I don't want to downplay what you are doing. I think it's extremely important. But I just want to convey that sentiment that how can we I'll be curious to know from you, how can we manage this so that we'll make it accessible with ease for users, right? I know I
Bilal,
looked
can I
at,
come in with my point is
sure.
exactly the point you're making. So I'm just going to pile onto
Yeah,
this
yeah,
really
please
quick.
go ahead.
Bilal
I'll
and I think
stop.
too much alike. I think, you know, one of the things that we know at NOAA is that Congress has given the authority to forecast to the Secretary of Commerce and through the National Weather Service. And so the authoritative source for all forecasts, including things like frost and cold wave signals, meteorological information for agriculture and commerce, all of that is officially supposed to come through NOAA. And we have incredible collaborations with USDA and USGS. And I'm really glad to hear that you're working with NCEP because that's where a lot of this starts to work through the test beds and everything. But like we know there's a huge need here. So I would just I'm gonna put an exclamation mark on what Bilal says, say that NOAA has the like unique mandate from Congress to do this, like to get these forecasts out. And we really, I think, need some of the thought power that you're putting into this to try and help move us to the next level. And I will add to that, it's not just thought power, but also supercomputing capacity, because you all have more than we have. So sometimes it just comes down to computer runtime too. So I feel like there's huge opportunities to collaborate here so that we can get that, what Bilal's saying, that authoritative information on storms and floods and frost and cold wave and all those good things out in a way that meets the challenges of what people need in a changing environment. So I want to thank you for what you're doing. Say I'm super glad you're working with NCEP and like let's try and do better together. So just exclamation point on everything Bilal said.
That's good.
All right.
That is music to my ears, right? Like I think Bilal, to your question or your comment, right? I also the whole reason I started this line of work was like years ago during my dissertation. It was like there's no good data. Where do I get good data? And like there's all these different sources of climate data that I could incorporate into. At the time, it was transportation asset management applications, but when I came to Argonne, we had lots of these massive data sets that no one was leveraging. And it was like, could we find a better way to serve up data in a way that end users and decision makers could more effectively leverage that? And so I want to go back to one comment Jordan made or very early in the presentation that I view Climber as a portal and the data that's on Climber as two very, very different products, where we are working with the data that we had most readily available because it's data that we know how it was created. We've got all the data on servers here, but all of the lessons that we've learned in creating a portal to serve up that type of data could be easily applied to other types of data sets. In particular, how we've worked extensively with the utilities and emergency managers and folks who could be end users of the data to understand like exactly and very specifically what they need to know in order to plug data into a decision, right? Like my whole goal is that an end user does not have to overhaul their decision processes to accommodate the data, but that we overhaul the data or tailor it so that it feeds directly into their existing decision processes. And so we've learned a ton as part of that process. And it's super encouraging to me that there's these types of discussions and these types of groups meeting to try and converge on a common data set or a common way of serving up that data And, if there's a way that we can contribute to that collaboratively, like that's what I want is to find a way to do that. And if it means that we're serving up data that's not our data, or we're taking the methodologies and things that we've created for the Climber portal and using that to inform a NOAA portal or someone else's portal, like we want to work together to find a way to sort of move this forward in a way that, well, to your point, does not confuse end users. And to the other point, Andrew's point about NOAA being the authoritative source, we've been, I will say, like when we had other partners on the Climber portal, we relied a lot upon them for interagency coordination, and there was a tremendous amount of activity under the previous administration, and I think that we had a difficult time connecting with the right people. I will say over the last year, I think we've started to connect more with the right people at NOAA and other parts of government, because really, we also recognize that NOAA is the authoritative source and would love to find a way to take everything that we've learned and contribute that to their activities to serve up data and information that's as useful as possible to the American public. So I'm wildly on board with collaboration and trying to converge towards a more common data set or common resource, as opposed to have a bunch of fragmented resources across the federal space, which I agree doesn't really help anybody ultimately.